Um, I was just told to share why I picked 1-chloropropane as the correct answer. And it was because in order to become propanoic acid, you have to have a double bonded O with the OH on the end of the molecule. And if you have 2-chloropropane, the chlorine in the middle would also have to be radicalized, and it would just be much more complicated.
Thank you, thank you. So yeah, there's no other way around it. Um, let's draw them out quick in case you didn't get a chance to. And a lot of you got it correct in the chat, so I'm hoping that means that you're feeling confident about it. Just in case, though, you had any concerns about it, let's draw them out. So 1-chloropropane, 1, 2, 3, with a chlorine here. H, and then 2-chloropropane has that chlorine right in the middle here, which is harder for reactions to occur because there's more stuff around it. Now for these to initially get closer to becoming something like a carboxylic acid, we need an oxygen. So the first step is going to be a substitution. Change this. So first we're going to have a substitution where an OH is going to come in and substitute with that chlorine or with that chlorine. So if we rewrite it, after the substitution, we have the same base. All of my carbons and hydrogens are the same, but now instead of the chlorine, I have a OH, a hydroxyl group. Sometimes I wish I could write a lot faster.
Handwriting is so much better than
Thank you. Okay, so now we have a primary alcohol because it's only got, let's highlight it. So this OH that's bonded to this carbon only has one other carbon attached. So that one's a primary. This one though, my OH carbon has 2 carbons attached to it. So that one's secondary. And a good thing to memorize is that primary alcohols can become aldehydes, and then they can become carboxylic acids. Secondary though, they can only become ketones. And like Zach was saying, we couldn't have a carboxylic acid where it's on the second carbon because it has to be on the end. That was one of the things that we said was a requirement of a carboxylic acid. So what's happening, again, we don't need to know specifics, but to start out, the OH and H versus just the H and OH there, they would become these things, H, C, double bonded O. And again, we don't need to know specifics on this bit. And then this one for a ketone, we've got HC, H, H, double bonded O there. And then this can't go any further, no more oxidation. But this one can, and this is where we get that carboxylic acid. So we're replacing the hydrogen on the end with an OH, double bond O, or a carbonyl group. There we go. So it was the one that gave us our answer.